Hi, people. How are we doing? We are on number six, systems of linear equations, and we're going to learn how to do it one final way. And this is to use matrices. Now, matrices by hand are kind of a pain. It's kind of a rite of passage. It's one of those things you do. Um, Eventually, you'll be using your calculator for these. Okay. That's actually going to be the answer to the second one here. I was just checking to make sure it had the right answer, that things worked out nicely. So eventually you'll be able to use a calculator, or you could plug it into some website. There's a lot of websites out there that solve matrices, right? So um, anyways, we're just going to jump right in. We're going to show you a pretty easy problem. We're going to show you kind of a classic problem, and then we'll show you how to use your calculator. Okay. It's a great way to check your work. All right, so here we go. Let's go back. This is actually a problem that we did a little bit ago. Um, so we're just going to redo it and see how it kind of is the same thing as using a matrix. All right, so step number one when I did this problem was I multiplied both sides by -2. The reason why is I needed this to be a -4y so it could zero pair out that positive 4y, right? So let's just rewrite these. 5x plus 4y equals 22. And then down here we had -6x minus 4y equals -24. What do we do next? It's elimination, so we added them together. Okay, so 5x plus 6x is going to be -x. Zero pair it out equals -2. I don't know if I did this. I think we just kind of could see the answer, but technically we're going to multiply this by -1. So we get positive x equals 2, right? And then what do we do after that? We plugged it into an equation. We plugged it into one of the two. I'll use the second one this time because I think I used the first one last time. Equals 12, right? So I use the original equation, 6 plus 2y equals 12. Subtract 6 from both sides, subtract 6, 2y equals 6, y must be 3. So my solution is 2 comma 3. There we go. All right, so we did this before. There's the answer using elimination. Elimination is probably the way I would do this problem if it was on a test and I had the option of doing anything I wanted. I wouldn't use a matrix, but matrices are kind of cool. I want you to see how it looks. There's an entire class called linear algebra um, that deals with matrices. Um, and you learn kind of faster ways to solve than the way we're going to do it here. So the matrix we're going to use is going to be 3 columns. And the person who invented matrices was like, hey, why don't we know that everything in that first column is going to be an X. I mean, look down to this problem. Like these are all X's, these are all Y's, these are all Z's. I hate having to write X's and Y's and Z's all the time. Why don't I just keep them in columns? And that's going to make things easier. And that's what the person did. Okay, so they invented matrices. These are my X's, these are my Y's, these are my constants. Now, somebody came along and for an equal sign, they put a line there. When you do that, it's called an augmented matrix. I like using that because it's basically the equal sign, right? 5x plus 4y equals 22. 3x plus 2y equals 12. Okay, so that's what these look like, and you can see how it relates to what's over here. It's the same thing, it's just the numerical coefficients, right? No variables in here. But these are the variables. This is the x's, these are the y's. Cool. All right, so what we do is this. I'm just going to do it, and we're going to see how it relates, and hopefully that's good. I'm going to tell whoever's grading this or myself as I do this, I'm going to tell them what I do. So this is row one, this is row two. I'm going to take row two and I'm going to multiply it by -2. Okay, so I'm showing the viewer what I'm doing. Okay, I'm going to move this over so I have lots of room. I didn't do anything to the first row, so it's just going to stay there. But the second row, I'm multiplying by -2. -6, -4, -24. Cool. Does that look familiar? Yeah, that's exactly what I did here. Notice it's exactly the same, except these are my X's, these are my Y's, and I'm not rewriting them. Okay, it's kind of nice not having to write those all the time. All right, next thing I'm going to do is I'm going to add them together. I'm going to say row two plus row one. And notice when I write something on the side, I'm identifying which one I'm changing. So I didn't write anything on the side here, so it's going to stay the same. Okay. I wrote something here, so that one's going to change. Okay. I wrote something here, so the bottom one's going to change. So my top one does not change. So 5, 4, 22, those don't change. But I'm going to add the two rows together for my new second row. So 5 plus -6 is -1. 4 plus -4 is 0. And then 22 plus -24 is -2. Cool. All right. I don't like this being a negative, just kind of like I didn't like it here, so I multiplied both sides by -1. Do the same thing here. Row 2 times -1. So now I've got 5, 4, 22, because I didn't do anything to that one. And here I multiplied everything by -1. So that's going to be +1. That's still 0. Now that's +2. Now think about what I have, right? When I did that in the last problem, I got x equals 2. Look at what I have here. This is the x column, x, 1x. There's no y's. So 1x equals 2. I've got one of the solutions. Now I just need to do the y solution. So to get this one, I need to make this a 0 because right now it's got 5x's and 4y's. I need to eliminate the y or the x value here. So I'm going to take row 1 and I'm going to subtract 5 row 2's like that. Okay, so I'm going to go 5 times row 2, right? And then subtract that from the first one. So let's do it. 5 minus 5 times this. That's 0. 4 minus 5 times this. That's still 4. 22 minus 5 times this. So 22 minus 10. That's 12. Yeah. And I didn't do anything to the second one, so I'm just going to rewrite it. 1, 0, 2. Put that there. I'll put my little equal sign in there. And I'm pretty close here. This one, I just want to divide it by 4. And you can just do this too, right? You don't have to say, when you're doing something like this, I want to show my work and show my thinking. I'm dividing by 4 here, right? So 0 divided by 4, 4 divided by 4, 12 divided by 4, and 1, 0, 2. And there we go. Some teachers would want you, I don't care. They might want you to flip the two rows. Okay, so you could do something like this. So 1, 0, 2, 0, 1, 3. They like that. It puts it in kind of a nicer order. Your calculator will put it in this nice order for you. But basically this means this: x is equal to 2, y is equal to 3, 2 comma 3, which is exactly what we got before here, which it should be the same, right? Cool, cool. So if you had to choose between the two, which one would you use? Everybody would say elimination, I think, unless you're like me and you just kind of like doing this because it's kind of fun. All right. So it's more useful when you have bigger things, right? And it's harder to figure out. So this is a classic when you might use a matrix rather than elimination method. It's a 3 equation, 3 variable problem, although elimination is still great for this type of problem. Okay, but we're going to jump in and I'm just going to take you through it. Let's see. So my X column will be 1, 1, -1. My Y column will be 4, -5, -2. My Z column will be 2 and 3 and 2. And my constant column will be -4, 16, and 8. Cool. Cool, cool, cool. All right. So you can see up here the final, like when I'm done, I have ones and zeros, right? I have 1 in this column and a 0. In the other column, I have a 0 and a 1. Same thing going across: 1 and 0, 0 and 1. That's the goal. Okay. At the end of this one, I want it to look like, take this out real fast. The goal is going to be that I have a 1, a 0, a 0, and then some number, and a 0, a 1, a 0, and then some number, and a 0, a 0, and a 1, and a number, because that would be x equals this, y equals this, z equals this. So this is my goal. This is hashtag goals right there. Dang, I just dated myself. All right, that's okay. Here we go. So how do I do that? Well, I pick one column. See, there's lots of ways to do this, but I usually pick one column that looks like it might be easy to eliminate a couple or to turn them into zeros by adding lines together. Again, this is related to elimination. So let's watch this. If I took row one and I added it to row three, what's going to happen? 1 plus negative 1, 0. 4 plus negative 2, 2. 2 plus 2, 4. 8 plus negative 4, negative 4 plus 8, positive 4. Cool. Nice, right? I got a 0 there. That's great. What if I did the same thing here? I can do 2 for 1. What if I also added the second and third row together? So row 2 plus row 3. All right, let's do it. 1 plus negative 1, 0. Negative 5 plus negative 2. Ew, negative 7. 3 plus 2, 5. And that's going to be 24. Cool. Cool. Look at that. I got a 0 and a 0. I'd like this to be a 1, but right now it's a negative 1. How could I undo that? Multiply by negative 1. So negative 1 times row 3 is my new row 3. So multiply everything by negative 1, positive 1. Multiply this by negative 1, positive 2. Multiply this by negative 1, negative 2. Multiply this by negative 1. That's negative 8. And check that out. That's exactly what I want. I want a 0 and a 0 and a 1. Beautiful. Absolutely beautiful. So happy. So happy right now. All right. The next thing I'm going to do is I want to make a 0 here and hopefully a 0 here. Okay. That's my goal. Okay. If I can get a 0 here, I'm on my way. And I see if I just subtracted row 1, I've got it, right? So if I take row 3 minus row 1, I'm going to be able to turn this into a 0. So row 3 minus row 1. I'm telling the customer just what I'm doing here. I might be able to make more than one move, but for right now, that's it. And notice what's happening. I'm telling you what I'm changing, right? This is going to be the final row changes. If I don't do anything else, I'm just going to copy the first and second row as they are. As of now, this is the only row that's going to change. So row 3 minus row 1. 1 minus 0. 1. 2 minus 2. 0. Negative 2 minus 4. Negative 6. Negative 8 minus 4. Ooh, negative 8 minus 4. Is that negative 12? I believe it is. I believe it is. There we go. Okay. Let's see, what else do I got? Ugh, these are like that negative seven's nasty, right? It's not a happy time. But well, how about this? Let's divide this one by two. I see everything's even. Maybe that'll make things easier. Okay? So I'm going to do row one divided by two. I could just write divided by two. So that's going to be 0, 1, 2, 2. I didn't change the middle one. 0, negative 7, 5, 24. Okay? Now, my goal, I have a 0, 0, 1 here. I have a 0 and a 1 here. What do I need to make this one? Yeah, right. Oh, sorry. I should have put that up here for those of you yelling at the screen right now. That goes up there. All right, that's right. That goes up there. All right. How could I eliminate this right here? Oh no, what happened? Hold on, I'm gonna pause. All right, I'm back. Whew. My camera dropped out on me. Like the instant blast of Mr. Reeboff in your face. That had to be scary. If you need to take a break, pause now. Get yourself together. All right, so how do we make this a 0? We need a positive 7, right? So I'm going to go 7 times this row and add it to this row because that would be 7 plus negative 7. That's going to give me a 0 there. And that's what I want, right? I want zeros and ones. Definitely don't want a negative 7. So I'm going to do row 2 plus 7 times row 1. Okay? I'm going to come up here for this next one. And I think that's all I'm going to do in this step. So I'm going to copy down the first one. 1, 2, 2. I'm going to copy the last one. 0, negative 6, negative 12. And I'm going to take care of this now. So row 2, negative 7 plus 7 times this. So negative 7 plus 7, that's a 0. Oh, this was already 0, right? So 0 plus 7 times 0 is 0. Negative 7 plus 7 times this. So negative 7 plus 7 is 0. 5 plus 14 is 19. And then 24 plus 14, remember I'm multiplying this by 7 to add to this. One of the things you can do, if it becomes kind of big like that, grab a little thing like this. And if you want to, multiply everything here by 7, right? And then you could kind of bring this down, right? Because this is what I was doing in my mind. It makes it a little harder. Now you can add 0 plus 0 is 0. This is 0. That's 19. That's going to be 38. When that got to 19, I got a little scared. But as soon as I saw that that was 38, I got a little not scared. All right, divide both sides. Divide this one by 19. Let's see what we got. 0, 1, 2, 2. 0, 0, 1, 2. And 1, 0, -6, -12. All right, so let's look at what we've got. We've got 1, 0, 0, 1, 0, 0. So this one over here needs to be 1, 0, 0, right? So I need to make this a 0. I'm going to circle it just to show what I want to do. And I need to make this a 0 because then I'd have a 0, 1, 0. I'd have 0, 0, 1. I'd have 1, 0, 0. That's the goal, right? Is to have zeros and ones. All right, so how can I get rid of this 2? I'm going to take row 1 and I'm going to subtract 2 row 2s. Okay, so let's do that. So 1 minus 2 times this. Or sorry, 0 minus 2 times this. 1 minus 2 times this. 2 minus 2, 0. 2 minus 4, -2. I'm not changing the middle one. The middle one is done. It is in great shape. So I'm just going to leave it there. All right, for the last one though, to make this a 0, what do I need? I need 6 times this plus this. So I'm going to do row 3 plus 6 row 2s. Okay? So again, if you needed to, you could grab a piece of paper and be like, okay, 6 row 2s, that's going to be 0, 0, 6, 12. And then you could add these together, right? This one's kind of cool. So row 3, -6 plus 6 times this. So that's going to be a 0. Oh, sorry, I should start here. 1 plus 6 times 0. That's going to be a 1 still. Oops. 1. 0 times 6 times 0 is 0. -6 times 6 times 1. So -6. Sorry. -6 plus 6 is 0. And then -12 plus 2 is 12. So -12 plus 12 is 0. Beautiful. Beautiful. I'm good. And this isn't bad. Okay, what this means is x equals 0, and that's fine. Remember, it's only when all the variables drop out that we have a problem, right? This is totally fine. So if I was to write the solution right now, x is 0, y is -2, and z is 2. Now, some of your teachers would want you to rearrange things. They'd want this to go to the top. They'd want this one to move down, this one to move down. So you'd have 1, 0, 0, 0. You'd have 0, 1, 0, -2. And then you'd have 0, 0, 1, 2. And we've got that nice, if I did the augmented style, we've got that diagonal of ones and everything else is a 0. So a lot of teachers would want you to do this. I don't care. Once you get here, you know what the answers are. So go ahead and write it down. Totally fine. Cool. Again, is that easy? No. Okay. And you have to be very meticulous and very careful. So let's talk about how to do this on calculator. All right. So using RTI 84 to solve matrices, it's going to be like that. It's going to, oh, it's a little more than that. It takes about 3 steps. 1, 2, 3. So matrix, there should be an I there. I don't know why there's not. Maybe on the old calculators. Oh, that's why I did it. Look at this. Old calculator. Oops, sorry, you can't see. Old calculator matrix, no I. New calculators, they could have, that's why you pay more for this one because they have the I there. Okay, that's crazy, right? You're paying probably $50 more just for that eye right there and some cooler colors. That's all. Okay, so we're going to go matrix edit. So matrix is second x inverse. So you see x inverse right there. It's the 4th one down on your left. We're going to hit the blue second button if yours is blue. If you have old school, it's yellow. right? But your second key and then matrix. Matrix gives you three options. You work from the right to the left on this. So we're going to start with edit. We're going to press enter. The first thing you have to do is choose the rows and columns. So how many rows did this problem have? One, two, three rows and four columns, three, four, 3 by 4, enter. Notice it now looks, it can't hold all of it, but it's got three going down and it's got one, two, three, four going across. Okay. Sometimes you'll forget, you might do columns times rows and you'll be like, okay, and then this does not match this, right? You'd be like, oh, I must have mixed those up. That's okay. You don't have to be perfect, people. Okay. Sometimes we go, oops, did it wrong, fix it. All right. Next thing we're going to do is we're going to enter the numbers just like this. We want this to look like this. So one, that's going to go across, 4, 2, -4. Make sure you use negatives, right? Make sure you use your negative, not your minus. So -4. And then the next one is 1, -5, 3, 16. Next one is -1, -2, 2, and 8. Press enter. What I like to do real quickly is just to quickly double check. 1, 1, -1, 4, -5, -2, 2, 3, 2. And then the last one, -4, +16, +8. Good. Do a quick double check. It's easy to mess up something or put a decimal or do something weird. All right, once you've done that, we're going to get out of it. We're going to go second. We're going to go quit. So I'm back out to the main screen. Okay. Now we're going to go matrix math. That's the second one. So second matrix. We're going to go to math this time, and we're going to go to ref. Okay, ref. That stands for row reduce echelon function. Okay, ref. So I'm going to go down until I see ref. There's ref and there's ref. We want ref. Okay. So ref, I'm going to press enter and it says, what do you want me to ref? And we want it to ref matrix A where we put all that information in. Okay. So now I'm going to go to matrix again, second matrix. And this time I'm just going to go to names. So notice we went edit first, then we went to math. Now we're going to names. We're working from right to left. Okay, so we're going to press enter. It's going to say ref A. We press enter and watch the magic. Boom. How does that look, people? Let's compare. Nice, right? So matrix on your calculator, so easy. And there's probably online stuff all over the place and the internet. You're just plugging in the coefficients and boom, with a press of the button, you've got the answers. This would work for this problem right here. So it's a great way to check your work rather than plugging these back in. In fact, if there was a big problem like this and I said solve this by using a matrix by hand, the first thing I would do is I would cheat and make sure, just see what the answers look like, right? So along the way, I could kind of check and see if I was making mistakes. So that's it. That's it. Matrices. Whew, we did it. We'll see you, people.